Good morning and welcome to a terrific Math Tuesday. Thank you for showing up for your learning. Today's topic is 4.1, Introduction to Linear Equations. Let's take a look at all of our problem types. Here we have a problem where we've been told that 40 is the same thing as 32 plus 2 W's. And we want to find an expression that would communicate that as well in mathematical form. So you do need to be able to manipulate your equations to make something like this true. First of all, I can write out 32 plus 2 W's. Well, that would be equal to 40. And I look through here and I don't find exactly that. But I find one that has all the ingredients, and we'll see that this one is true. If I subtract 32 from both sides, then I will have rearranged this to be 2W equals 40 minus 32. So this is correct here. And this is how we can read these types of tape diagrams and answer these problems. So let's keep going. One more. Here we have 2 plus W equals 5. So here is W plus 2 equals 5. So that one is correct. And this is how you can think about these problems. It's a good way also to visualize these types of problems when you encounter them in other forms. So now let's take a look at words to expressions. So here we want to create an equation based on the words of the problem. And a number is the letter x. So 2 times a number, well, I would write that this way, 2x. Good. And then let's do another one. A number is doubled. Okay, well, I'm going to double a number, 2x, same answer. Okay. And then 3 times a number, well, that would be 3x. Then the product of 2 and a number, the product means multiply, so that's 2x. Good. And then a number is subtracted from 2. Okay, so I have 2, and then I subtract some number. So there my number is x. And so I have 2 subtract that number. Okay, and that's how we will do these types of problems. Now, we will also have compound ones, which are more challenging. Check these out. The product of 7 and the square of a number. Oh, okay, so I have to multiply 7 and some number squared. Okay, so this is the product of the square of a number. Okay. So I just want to take a look at that, break this one down. I take 7 and I multiply it. That's what product means. I multiply it by some number squared. And so here is some number squared. Good. Okay. The product of 2 and the difference of a number and 5. Okay. So I'm going to take 2 and I'm going to multiply it from the difference between a number and 5. That is correct. The difference of a number and 5 is x minus 5. And the product of 2 and x minus 5, the way we write that down is this way. So there you'll recognize that we would need our distributive property to simplify that. Okay, let's keep going. Now, we want to also be able to look at graphs and understand what that means. So here's a question about Scarlett. Okay, she's practicing the piano for the same number of minutes each day. The relationship between the numbers of days x, and remember x is always written first in these ordered pairs, and the total number of minutes practiced is y, is represented on a graph. And if the point 250 lies on the graph, what does that indicate? 250. She practices 50 minutes a day for 2 days? No. A total of 50 minutes over 2 days would be correct. Okay. So this indicates that 2 days have passed, and this indicates that 50 total minutes have been practiced. Okay. And so that would be this one. And then that's true. Let's do another one. A grocery store sells sliced Swiss cheese by weight. The relationship between the amount of Swiss cheese in pounds, x, and the total cost in dollars of Swiss cheese, y, is represented here. Okay, so this would tell me that 2 pounds cost $9. Okay, so 9 pounds of Swiss cheese cost $2? No. 2 pounds of Swiss cheese cost $9. Each? No. 2 pounds of Swiss cheese cost a total of $9 will be correct. So we need to be able to interpret these types of things and understand them. If we are confused, we absolutely want to read their explanations for some questions that we don't get. Okay, and we also will take a look at some graph stories. Here is one spring day. Rashawn noted the time of day and the temperature in degrees Fahrenheit. During the time, the temperature rose, stayed steady, and fell at different rates. So here is the temperature rising, here's the temperature staying steady, and here's the temperature falling. All right, and here's time. As time goes along, we notice that the warmest time of day is afternoon. This doesn't surprise us. And then it gets warmer through the morning and gets cooler in the afternoon, and we have all the temperatures over there. So then we're saying, which of the following statements is true at the temperature at 8 p.m.? So we go ahead, we go 6, 7, 8, and we go up from 8, and we find that the temperature is falling, and it's around 67 degrees. So it was dropping at a rate of 3 degrees Fahrenheit every 1 hour. I think that looks correct. If we go 1 hour here, yeah, look, it falls from here to here, falls 3 degrees. So it's falling 3 degrees every hour. That's my answer. Hooray! Okay, let's do one more. All right, one spring day. Tanisha notes the time of day and the temperature in degrees Fahrenheit. All right, so again, similar temperature graph. What's the following is true of the temperature of 1 p.m.? So here it is 1 p.m., and I come up here from 1 p.m., and I notice it's rising at 2 degrees per hour. Okay, it was rising at 2 degrees Fahrenheit every 1 hour. How do I notice that? Well, I see that it goes over 1 and up 2. So I have to be able to read that slope. Submit that answer. Yes. Good. Okay. So these are various linear relations that we are investigating. And then we can also look at tables of values and see patterns. So here I notice that the x value is increasing by 1 every time, and the y value increases by 4 every time. I add 4 to all of these numbers. The next one will be 14. See the patterns, okay? So spot the patterns here, 10, 12, 14, 16, 18. I add 2 every time. You have to spot the patterns. Okay, so work to spot the patterns. If there's something you can't get, take a look at their explanations when you get it wrong. And that's okay. It's okay to look at their explanation and learn something new. It's the main idea. All right, now here we go. The graph of a function is shown on the coordinate plane. Okay, identify the rate of change. So what we're asked to do here is notice how much this graph is changing over time. In order to do that, the best way is to find one of these points where it goes right through one of the intersections in the grid line. Here I notice the point is at 0 in the x and -3 in the y. And then it rises, 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 rises. It almost hits an integer point there. It rises, and there's an integer point right there. So it's risen from -3 to 4, and it's moved over to 4. So the way we write down rates of change here is I'm going to need my paper to show you. What I've noticed is that this function, it has an intersection down here at the point 0, -3. And then it has a point over here, which was at the point 4, 4. And it goes right through the center of those points. And then what I want to do is say, well, while this is growing, how much does it grow? For how much does it move? And so that would look like, come on, there. It rises 7, and then it runs 4. Okay? And these triangles here give us what's called the slope of these lines. So if I'm looking at how much does it go in the x compared to how much it goes in the y, this is called a run because it runs along the x and it rises along the y. The slope, we're going to just use the letter m for that for now. The slope is equal to rise divided by run. And so that's the rate of change. Okay? Rates of change could be like kilometers per hour or dollars per hour, something like this. Okay, and so here the rise was 7, and the run was 4. So this is the rate of change, 7 over 4. 7 over 4, enter, enter. Hooray! Let's take a look at another one. Okay, what is the slope of the function y is equal to 2x plus 2? Well, y is equal to 2x plus 2. Here it is written out, 2x plus 2, and this is the slope. Whatever the coefficient of x is your slope. And we'll take a look at some examples of that together soon. But for now, that will get you through those problems if you've gotten this far. The graph of the function, identify the slope. So here, again, I'm going to make a sketch. So I have this graph here. It's going to cross the y-axis there at the point 0, -1. Okay, and then it also crosses up here an integer point at 1, 4. So let's put that point on there. This is the point 1, 4. All right, this has a positive slope. We're going to use blue. All right, and I notice that it rises 5 and runs 1. It rises 5 and runs 1. -1 goes up to 4 by 5. 0 goes over to 1 by 1. Okay, so that's where I get these numbers. And then we would have the slope is 5 over 1, or that's just equal to 5. So let's put that in. 5. That's my answer. Okay, let's take a look at another problem. So then we're going to work from tables. So here we go from the point -4, 4. That's the first point in the table here, and then that runs all the way to 0, -3. So it ran from -4 to 0. So we want rise over run. Let's first do our run. Our run is our change in x. So -4 goes to 0. So that actually got bigger by 4, plus 4. And then 4 rose to -3. If it went from 4 all the way down to -3, this is from +4 to -3, that would be a rise of -7. So here my answer would be -7 over 4. Put that in. The rest, I'll let you figure out. Okay, so that'll do. That goes. So now, we will also take a look at tables to linear equations. I've given you all 3 levels, and these you have to create your own linear equations. Okay. For today, see if you can do it. I'll show you some. But we will be working on this, so if you don't get it today, do not feel disheartened. We will practice this a lot. So below is a linear function in table form, and I want to write it in slope-intercept form. The first thing that I need to do is find the slope. Okay, so I'm going to take the points 0, -6. That's this point here. And then this point 1, -4 goes to 1, -4. Okay, so the way I do this is first I'm going to get my rise over my run. Run is change in x, so let's go for that. 0 goes to 1. Okay, so that's an increase of 1. -6 for my rise goes to -4. That's an increase of 2. So this tells me my m is equal to 2. Okay. Now, what I'm going to do is, now I know that for every change in x, there's a change of 2 in y. So I'm going to have an equation that's going to look like this. Y is equal to 2 multiplied by x plus some number. Okay. Why is it plus some number? Because if y was just equal to 2x, here 0 in the x would give me 0 in the y. But that's not the case. So what I can do is take one of these points to substitute in and solve for this number b. So I also know that like x, y, one of these points could be, I'm going to take this one, 1, -4, 1, -4. So what I'm going to do is put this point into this equation like this. -4 for y is equal to 2 times 1 plus some number b. Now I can notice that if I have here -4 is equal to 2 plus some number, Well, that number must be negative 6. Because if I subtract 2 from both sides, because 2 times 1 is 2, then I will have negative 6, this is 0, is equal to b. Okay, let me write that out a little better for you. I'll do another point. I have y is equal to 2 multiplied by x plus some number b. Let's take the point 2, negative 2 here, and we'll substitute that in. So I'm going to put in negative 2 for y is equal to 2 times 2 for x. And I should get the same answer for b. Evaluate. Negative 2 is equal to 4 plus b. Subtract 4 from both sides, and I get 2 minus 4 is negative 6 is equal to, this is 0, b. So that, now I can put that number in there, and that gives me my equation, y is equal to 2x minus 6. This is hard for today. We will be practicing this a lot more over the coming 3 weeks. Think of today as your introduction and trial by fire. All right, everyone. That will go for sure. It is correct. All of the problems are the same types. So here is a level 3 one. I go from 1, negative 7. I'll do this one, and then I'll sign off. So let's see. I go from the point negative 1, 7, negative 7. That's the first point. To the second point, 1, negative 1. So for my rise over my run, well, the x changed from here by an increase of 2. So that's my run. My y increased by 6. 6 over 2 is otherwise known as 3. So now I know I have an equation that looks like this. Y is equal to 3 times x plus some number. Now I substitute one of these points in, and I'm going to choose this one. Actually, I'm going to choose this one, 1, negative 1. So I have negative 1 here for y is equal to 3 times 1 plus b. Subtract 3 from both sides, because 3 times 1 is 3, and I have negative 4 is equal to b. So I take this, I put it in there. Y is equal to 3x minus 4. Plug that in. Y is equal to 3x minus 4. Enter, enter. Hooray! So I hope that your math practice is fruitful today. You can email me with questions or come by at lunch if you have questions, and I'm happy to help you with that in any way I can. Bye for now, everyone.